Hey, so welcome back to our fourth day strong of Derivative of the Day, where we have another problem today to solve. I'm going to write it down here. If you follow this channel on Instagram, you would have seen it. Actually, what am I saying? I post these at 4:30, these videos, but I don't post the Instagram till a little bit later. So you wouldn't have seen this, but here's my working. This channel's also on Instagram if you just want to see it there, and then maybe see my working if you want. But so this problem here is different to what we've been doing lately because we need to use this thing called the quotient rule. And what the quotient rule is pretty much a way where we have, well, it's pretty much when we have a function on top and a function down bottom and they're like being divided together, we use it in order to derive the function. So I'm not going to, this isn't like really a tutorial or anything, so I'm not going to go too deeply into how it works and that, but I'm just going to state it quickly, just so any of you who haven't seen this before can attempt this yourself. I'll explain it slightly. So we have g of x dash x minus. I've learned this rule so many times, or had to use it so many times. Each time I have to re-look at it unless I've been practicing consistently. It's just one of those rules that I find I can forget. Which hopefully I won't now that I'm doing this every day. If you guys practice every day as well, you'll be able to keep on top of your game. So yeah, this is it here, and what we're saying is, just gonna grab like a highlighter or something. Let's go like, change color. Let's go yellow, make this like huge. So we have fx, and what this is saying is fx is our top function, g of x is our bottom function here. As you can see, this is quite similar, the resemblance in that, how it's formatted. Later on, we'll be mixing this with other rules and everything, but at the end of the day, you pretty much always have to use the quotient rule at some point in order to solve the derivative if you've got, well, a quotient in it. And what we're saying is, if we've got this function and we're deriving it, well, that's what this bracket and the prime there is, we turn this function into this statement here. I can actually get rid of this. This function, well, when derived, it looks like this, and then we simplify it. So, what color now? Let's go blue again, darker. So in our case, we have, as you can see, we've got f of x and f dash x, g of x and g dash x. So it's usually a good practice to write them down first. So our f of x is 2t squared plus 1. Our f dash x, which is just the derivative of f of x, is, well, we bring down the 2 and times, or 2 2s are 4. This is just the power rule. T, and then we subtract 1 from the top, so we've got a 1 there, but we don't have to write it, and then the constant at the end there, we can just leave as is. Oh, well, no, delete. Or not include. was a bit too hard to get out. Um, g of x now is t plus 1, as it says in the bottom. So g dash x, deriving it. Remember, there's secretly a 1 up there. So we bring the 1 down, subtract 1, and we get up the top, and we get 1. And then the constant at the end of here like disappears. So we're just left with 1. Now what we can say is the derivative of the function s with respect to t is g of x, so t plus 1, put some brackets, times by the derivative of f of x, so f dash x, so times them together, minus, and then f of x, 2t squared plus 1, g dash x, 1, and then all this is over g of x, t plus 1, and that's squared. And that there is how we applied the quotient rule in order to derive the initial function. So now what we're going to do is just simplify it. So how we're going to do that is by just expanding it first in order to combine all the like terms. So let's try to get a similar color. So we get, by expanding the first term here, we get 4t squared plus 4t minus 2t squared. And since this is actually secretly like -1, we're actually timesing by -1 here because there's a minus sign in the front. So that turns the positive into a negative, and then this positive sign here actually turns into a negative. Turns this one into a negative. It was +1 times -1 is -1. And t plus 1 squared. All right, so now we do 4t squared minus 2t squared. We'll equal this. And then see we have like terms here. I'll use a hat to denote the different orders. So we subtract the 1 hats together, then the 2 hats, but we only have 1 2 hats, we just add them in, 4t, and then we only have 1 3 hat, so we just include them in. By the way, if you're actually doing a test, don't use hats, because that actually means something else. It's just the first thing that popped into my mind to use. So yeah, we have this function here. I don't think I can further simplify this. I'm going to check this on Symbolab actually now, because I wanted to solve it with you guys without knowing what the end answer is. So new share. So this isn't a sponsorship or anything like that. I'm just literally doing it because this is what I use for uni to double check my assignments. It's no point. I don't, however, get answers from this because well, you don't really learn by cheating. So I've trapped it in. And here we are, 2t squared plus 4t minus 1 over t plus 1. Okay. And now if I go back, we will see that this is what we got. Awesome. So let's delete that. So we can say that ds dt, which is just another way of saying that, is equal to 2t squared plus 4t, it's a horrible t, minus 1 over t plus 1 squared. And there we are. So this is our final answer. There's nothing else to really add. So I just hope, oh my gosh. Yeah, I hope you all have a good day. I'll catch you here tomorrow for another video. Yeah.